Okay, so looking at the first problem, so it says, and also keeping in mind, there are going to be typically two products that are formed. There's a major product, and that's based on the movement from the high priority to the low priority. And if that doesn't ring a bell, then take a look at what we did 2 days ago. And then there's also another one where it moves in the opposite direction. That doesn't form as much. But on some of these, I'll show you both of them. And then on like this first one, there's really only one that's formed. So it says the reaction with hydrochloric acid with 2-methylpropene yields a 2-chloromethylpropane. So what's happening is we're actually going to start forming what's called carbocations. So this is where carbon can either have a positive charge or a negative charge, but it's for a very short amount of time. In other words, what's happening is in the intermediate stages where we break a double bond and form a single bond, there's got to be a point where one carbon's taking an electron and becoming more negative, where the other one's losing that electron and becoming more positive. So when looking at this, so we've got our draw it out here first. And I'm just drawing the hydrogens just to show that it's there. You don't necessarily need to show that. And then we're also reacting with hydrochloric acid. Now, when we draw the mechanisms, we don't want to put the HCl together. We want to show that single bond. So typically when you are putting it in an acid, we want to show how that bond is there. So same thing with the alkene. So what's going to happen is the hydrogen is going to donate its electron to the chlorine, which we all know from AP chemistry, strong acids. That's why that does that. So hydrogen wants to become a hydrogen ion. Over here on the other compound, so we've got really, if I rewrite this out, here, let me put that line there. We really have an electron here and here, but don't draw it like that. I'm just showing what is actually happening. So each carbon has an electron that it's sharing with the other carbon to form that double bond. But for a moment in time, this electron is going to move to this carbon. And as a result, what we're going to form on the other side is we're going to have a singly bonded carbon with our hydrogen. So everything's still the same on this part. Except now, so it's not so thick, this carbon is going to have a negative charge. Why is that? Because it just gained that one electron from the other carbon. So it's now got 2 electrons over there. So what do you think the charge on the carbon on the left is going to be? Positive. So for a moment in time, we have those 2 carbocations. And also what we're going to have is we're going to also have the hydrogen that has a positive charge and the chlorine that's a negative charge. And the hydrogen will move toward the negative charge, and then the chlorine is going to move toward the positive charge. So there's your nucleophile and electrophile. So the nucleophile is looking for the positive charge. The electrophile is looking for the thing that has the electrons, so it can now share the electrons. Yeah?
How are you getting that first drawing after the arrow from CH3C?
So this one going from here to here?
No.
I'm sorry.
How are you getting that from?
I'm sorry. What are you talking about?
The first thing to the right of the arrow.
The first thing to the right. This right here?
Yes.
Okay.
How are you getting that from the CH3C?
Okay, so again, let me redraw this and put the blue line back in. So we had the double bond, and we broke the double bond to make a single bond. And what happened is the carbon on the left gave away its electron to the carbon on the right within that alkene. So now for a moment in time, and again, this is very, very temporary, the carbon on the left has a positive charge because it lost an electron, where the carbon on the right gained an electron. Yeah, Mason.
So do we have to show all of that, like all the arrows?
Yes, yeah, you want to show all that, but I'm not done yet.
There's more?
There's more. Yeah, we're not finished yet. Yeah, Mary.
How do you know which carbon is going to
Great question. So remember from 2 days ago where we talked about priority. So this, I'm actually forming the major product. So which carbon, the one here, number 1 or number 2, which one has the higher priority? The 1, because it has those 2 methyls, and then the other one has just the hydrogen. So we're moving from where the rich electrons are at, so to speak. In other words, the left side has many, many more electrons than the right side. And so it's going to move away from that. Now, that we're doing in the next couple of days. I'm actually mapping that out so you don't have to worry about that. And then we'll revisit this again, I think, after Thanksgiving. But for now, I'm just producing the major product, which is we're moving from the priority. In other words, the electron is moving from the priority. And then our final product, so this here that I just circled is the intermediate. So that is the temporary, it's moving around, it's doing its thing. And then the final product will look like this, where you've got your singly bonded carbon. You've got a hydrogen there, a hydrogen here, and a hydrogen here. Now, what I probably should have done is here, let's do this. Let's make this hydrogen representative of that one. So that's where that went. And then, because I can. Yeah, you can go straight up and down. And then we'll have our methane here, and then what am I going to put on that carbon? Chlorine. Very good. And then we're finished. Now, you don't have to necessarily show the lone pairs, but if you wanted to for that chlorine, there it is. And that is our product that we just formed. And that is our 2-chloro, 2-methyl propane.
Can we do another one together?
I'm going to do another one together.
Do we have to worry about the second product on all of these, or do we just do the major product?
So this one actually told you what was being formed. These next 2 don't tell you. It just says the 2 products. Okay, so I'll do both of these for you. All right, so this one says that we have a reaction of HCl with pent2-ene yields a mixture of 2 additional products. Write the reaction, show the 2 products, show the mechanisms for the reaction. Now, since this one is a little easier to demonstrate with a chain, I'm going to show it like that. Actually, I'm going to show both of them at the same time. Okay, so our double bond is where? The 2, so it's between the 2 and the 3, okay? And we also have a reaction with HCl, so I'll put HCl here, because we have a major and a minor product. And it says that there should be 2 different products here, okay? So let's say that the one on top is favoring the priority. So which way will the arrow move? Will it move that way, or will it move that? Sorry, that's the same thing. Or will it move that way? The electron. The top one or the bottom one?
Which one did you say was favorite?
Which one's the priority? So I'm just looking. I'm asking, will the electron move the way that the arrow on top is showing, or the arrow on the bottom?
Bottom.
The top. Very good. So in other words, we're moving away from the priority. So if I look at these, so priority, there's a carbon, there's a carbon. So we're starting off with that. Here's a carbon, here's a carbon. So we're tied still. But then the next one is, there's a carbon. What are we hitting next on this carbon here? Hydrogen. Very good. Yeah, that's the more favorable situation when we're drawing these out. But again, this is asking for both the major and the minor, even though it doesn't say that. Correct. Okay, so for this first one, I'm going to do the major product. And so we want to draw the electron to represent the movement. And then on the bottom one, I'm doing the minor in there. Now, the nice thing about the HCl, it's the same on both. Okay. And so then on the product, or sorry, the intermediate, we'll go like this. And H plus Cl minus, and then I'll put this as well, plus H plus NCl. So now what charges, let's go ahead and put the charges. So if I'm looking at, say, this carbon at the top here, is that a positive or a negative? Very good. And what we want to do when we represent that is draw a negative with a circle around it. Don't ask me why they have circles around it. I think it's just so it pops out a little more. And this one's positive, where the minor, this would be positive, and this one would be negative. Okay? So that, say that again. Yeah, so now we're going to show how these guys move. So the positive goes to the positive, the negative goes toward the negative.
You did positive, negative, negative, positive.
Yeah, positive and negative.
You just said it different.
Negative, positive, sorry. Okay, and then, so then our final product would look like, let's go thicker again. So on this one, where's the chlorine going? Number 2 or number 3 chlorine, or carbon? 3, good. So we'll put our chlorine down there. And then this one goes to the number 2. That's it. And if you want to show the lone pairs, that's fine. Correct. The H is already in there. So it went from a CH2 to a CH3.
Do you have to draw the methyl line?
There is no double bond on the product side.
Okay.
They're all single. Say it again. I'm
So
sorry.
you don't need to draw the methyl line because it went to a CH3.
The methyl line.
Like because you just said.
Oh, okay. So let me clarify. If we looked here originally, this was CH2.
So since you added the hydrogen, did it just become a methyl?
So it became, no, I'm sorry. That was CH. My bad. So then it became CH2. So we added a hydrogen. Yeah. My bad. Thank you. Yeah.
How do you know that you're supposed to draw both major and minor?
It'll tell you 2 products. Try this one on your own, and I'll draw it up here. So try this one on your own. And both major and minor. So again, it's asking for the 2 products. Oh, let's use a different color. And what's derogatory? What?
It's my sister called me a Nugent. I don't know what that is.
What a what?
That's what I said.
What'd you just say?
That's what you said.
I don't know what you just said.
I'll tell you what I'm
And the top one, which way would the arrow go if I'm moving away from the major? Would it go like that, or would it go the top arrow or the bottom arrow? Top. So again, it's looking at what do we have here? So we've got essentially 2 carbons on that 1 carbon. So that one wins. Ah, get away from that.
Wait, so how do you move away from that?
What's that?
Because there are 2 carbons.
2 carbons versus the 1 carbon with hydrogen. Oh, let's put it back. I erased it.
I'm not seeing it.
Okay, well, yeah, there. Now you can see it.
Okay.
Sorry, I erased it. So that one will go like that, and this one will go like that. And then and so the top one, who is my negative, the number 2, number 3, number 4 carbon. Okay. And then this one goes the other way. So this is our positive. There's our negative. Let's make that a little bigger. So then hydrogen goes there. Chlorine goes there. And
I feel like this is beneficial. Thank you.
my pleasure. And so the chlorine would go down here. Ooh, I need to do that a little better. Okay. Questions?
Okay, wait. I do have just like a.
Okay.
Why, like, why
You're welcome.
do we do these? Are we just getting rid of the double bond? Or is that just
Correct. So this is typical for mechanisms when we have alkenes and we're going to react with an acid that it turns into an